Hello guys, in this video we are going to discuss the solution of the problem check if two line segment intersect. So let us look at the problem statement. The problem statement says that given the coordinates of the endpoint of P1 Q1 and P2 Q2 of the two line segments, check if they intersect or not. If the line segment intersect, return true, otherwise return false. So for instance, if the line segments are given by these points, and then we can see that the two line segments do not intersect each other in this case. That is why we are returning false. If they intersect, then we have to return true. So that's about the problem statement, folks. Now let us discuss the solution of the problem. So before we discuss the solution of the problem, let us understand one minor detail here. So the problem talks about line segment and not line. Please note that the problem talks about line segments. So what do we mean by this is, let us say these are the two lines which we have. So let us say this is my line 1 and this is my line 2. And let us say these two lines intersect at some point this. Now, if the line segment which is given to us is this, so let us say from line 1, this is the line segment which is given to us. So let us call this as line 1 and this as line 2. So from line 1, if this is the line segment which is given to us, and from line 2, the line segment which is given to us is this. So clearly, as you can see, the lines intersect. However, the line segment do not intersect. So this is one minor detail. So if PQRS is given to us in this case, then we have to return false. So this is one minor detail which I wanted to highlight. Now, once we have understand this, now let us begin with our solution. And since we are dealing with line segment and not line, because of which if we try to form equations like this and then try to solve for x and y, this is not going to work. Now, since this doesn't work, how do we solve this problem? Well, the way we are going to solve this problem is, now let us say this is a line segment PQ and another line segment, let us say RS. And let us say RS intersects PQ. Now, if RS intersects PQ, then with reference to PQ, what can be said about R and S? So if RS intersects PQ, then with reference to PQ, what can be said about R and S? Now, if RS intersects PQ, then if R is on the left side of PQ, right? So here if you see this is the line, and R, this point R is on the left side of PQ. So if R is on the left side of PQ, then S has to be on the right side of PQ. The right side of PQ. And this is what we are going to use in order to solve this problem, which is if there are two line segments and one line segment intersect the other line segment, then with reference to one line segment, and let us say in this case with reference to PQ, if R is on the left side of PQ, then S has to be on the right side of the PQ. And this is what we are going to use in order to solve this problem. Now let us discuss various cases here. So the first case is when RS intersects PQ. So this is PQ and this is RS. So we understand that if RS intersects PQ, then if R is on the left side, then S will be on the right side. Let us analyze the case where they do not intersect. Now, if RS does not intersect with PQ, so PQ could be this and RS could be something like this. So it does not intersect in this case. In this case, as we can see, both R and S are on the right side of the PQ. Similarly, it might be possible that this is my PQ and RS is this. So in this case, R and S are on the left side of PQ. And let us analyze one more case. So let us say this is PQ and this is my RS. So if you see in this case, R is on the left side of PQ and S is on the right side of PQ. So from here it looks like that RS is intersecting PQ, but clearly it is not intersecting. Then how do we rectify this? Well, in order to rectify this, apart from considering the point R and S with respect to PQ, we also have to consider the point P and Q with respect to RS. So if we look at the points P and Q with respect to RS, then we realize that both the points P and Q are on the left side of RS. So because of this case, what we are going to do is we are going to analyze both the points or all the points with respect to other line. So what I'm trying to say here is we need to analyze the direction of point R and S with respect to PQ. Additionally, we also need to analyze the direction of point P and Q with respect to RS. And once we analyze all these points, we will be able to conclude whether the two lines intersect or not, right? And there is one more corner case, and let us discuss that case also. So see, it might be possible that this is my line PQ and then this is the line RS, right? So in this case, you can see that the lines are collinear. Similarly, it also might be possible that this is the line PQ and then this is the line RS. So here also the lines are in the same direction, because of which it is not possible for us to understand the direction of point P and Q with respect to RS. Similarly, it is not possible to conclude anything from the direction of point R and S with respect to PQ. So what do we do in this case? So in this case, what we need to do is we need to just see whether a point, so this is a point which is an overlapping point, whether this point is in the range of P and Q. So R should be in the range of P and Q. Similarly, Q should also be in the range of R and S. So for this special case where the direction of PQ and RS are the same, because of which it is not possible to conclude whether P is towards left of RS or Q is towards right of RS. Similarly, it is not possible to conclude whether R is towards left of PQ or S is towards left or right of PQ. So in such case, all we have to do is we need to see whether the points are collinear and the points are within the range or not. So that's the general idea about this problem, folks. Now the two concepts which we need in order to solve this problem is how do we determine the direction of a point with respect to a line segment. So this is one question. And the second question which we need to answer is, in the case if they are collinear, how do we determine whether a point is on the line segment? So these are the two concepts, or these are the two questions. If we answer, we will be able to apply the logic which we have discussed in order to solve this problem. So in order to solve question 1, we are going to discuss a concept direction. And in order to answer question 2, we are going to discuss a concept which is known as on segment. So let us discuss the concept of direction. So let us say this is a line segment which is given to us, PQ, and this is any point which is given to us, which is R. Now we want to understand R is towards left or right of PQ, and we want to find out the direction of R with respect to PQ. So let me just write down the coordinates also. So let us say this is x1, y1, this is x2, y2, and this is some point x3, y3. So the first thing which we are going to do is from point P and Q, we are going to form a vector PQ. So this is a vector. And the way we will be able to form is, we just have to do this, x minus x2, comma, y1 minus y2. And this will give me a vector PQ. Similarly, we are going to form a vector PR. And the vector PR can be formed as x1, x3, comma, y1, y3. So once we have these two vectors with us, we just have to compute the cross product of these two vectors. So just for the sake of simplicity, let me just write it like this. So let us say x1 minus x2 is x1 and this is y1, and similarly this is x2 and this is y2. So the cross product if we do, and here we are just dealing with the magnitude, this will be equals to x1 y2 minus x2 y1. So once we have this value, whether this value is positive or negative, we will be able to assign a direction to it. So if the value is positive, then we can say that the point R is towards right of line segment PQ. Similarly, if it is negative, then we can say that point R is towards left of line PQ. Okay. And the cases where it will be 0. So for 0, it is the case where it is not possible to determine the direction. And in this case, this is a case of collinear points. Now let us solve this case also. So if this is a collinear point, then we have to check whether the collinear point is on the same segment or not, right? So here PQ is a line segment, and then it might be possible that R is somewhere here. Or the other case might be like this: if PQ is my line segment, then R is somewhere over here. So in order to conclude whether R is on the line segment or outside the line segment, we are going to use the concept of on segment. And in on segment, 3 points will be given to us, P, Q and R, where PQ is the line segment and R is a point. All we have to do is we have to check whether if R is less than or equals to P and R is greater than or equals to Q. So if R is in the range of P and Q, then we are going to return true, stating that this is on the same segment. Otherwise, we are going to return false. So that's the discussion regarding the two concepts, folks. Now let us look at the pseudocode for this problem. So as we know, we are going to use the concept of direction and on segment. So let us have a function around that. So let us say the first function is direction, and for the direction function we need 3 points, P, Q and R. So PQ is the line segment, or the point P and Q forms a line segment, and R is a point whose direction we want to identify. Now the first thing which we are going to do is we are going to form our vectors. So let us form our vector PQ, which will be equals to P0 minus Q0, and this is a vector. So in question, P is a list of 2. So P is a list which contains X and Y. So that is what I am doing here. So the X quadrant I have subtracted, and let us subtract the Y quadrant as well. So PQ of 1 will be equals to P of 1 minus Q of 1. Similarly, let us form the vector PR. So PR will be equals to P0 minus R0, and sorry, this is 0, and the Y quadrant will also be like this. So once we have PQ and PR vectors with us, we need to compute the magnitude. And the way we are computing magnitude is PQ of 0 into PR of 1 minus PQ of 1 into PR of 0. And in this way, we will be able to determine the direction of R with respect to line segment PQ. Once we have this concept sorted, now let us have our on segment concept also. So let's have a function around that. On segment PQ are a line segment and R is a point, and we need to find out whether R is on the line segment PQ or not. So for R to be on the line segment PQ, we have to just see if the X quadrant of R is less than or equals to max of P0 and Q0. Similarly, it should be greater than or equals to minimum of P0 and R0, Q0, sorry. And the reason we are doing min and max is because we are not sure whether P point is the minimum point or Q point is the minimum point. That is the reason why we are doing something like this. So this is regarding the X quadrant, and the same thing which we are going to do it for the Y quadrant also. So R1 should be less than or equals to max of P1 Q1. Similarly, it should be less than or equals to minimum of P1 and Q1. So if the x and y quadrant of point R is within this range, then we can conclude that this is on the segment, because of which we can return true. Otherwise, we are going to return false. So these are the two function, folks. Now let us discuss our main function, which is intersect. So 4 points are given to us, P, Q, R, and S. Whether the line segment PQ intersect the line segment RS is what we are going to determine. So the first thing which we are going to check is the direction of point R and S with respect to PQ. So let us use our function direction. So PQ is our line segment and R is the point whose direction needs to be determined. Similarly, D2 is equals to direction PQ and S. And once we have R and S direction, then we also need to compute the direction of P and Q with respect to line segment R and S. And RS is my line segment and the direction Q. So from our discussion, it might be possible that D1 is greater than 0. And if D1 is greater than 0, then D2 has to be less than 0. Or it might be possible that D1 is less than 0 and D2 is greater than 0. So one of these two condition is possible. This simply means is here R is right. R is towards right of line segment PQ and S is towards left of line segment PQ. And in this case, it might be possible that R is towards left of line segment PQ and S is towards the right of line segment PQ. So that is with respect to PQ line segment. And as we have discussed, we also need to consider the points P and Q with respect to line segment R and S. So for that reason, D3 can be greater than 0 and D4 can be less than 0, or D3 is less than 0 and D4 is greater than 0. So if this condition is satisfied, the fifth condition, then we can safely return true, saying that the line segments intersect each other. So if the condition is not satisfied, then we have to check for collinearity. So for collinearity, we have to see if D1 is equals to 0. So if D1 is equals to 0, then that simply means that the points are in the same direction. Once the points are in the same direction, we need to check whether they are on this segment or not. So on segment, PQ is my line and R is the point. So if R is within the segment of PQ, then we are going to return true. And the same thing we are going to check with other points also. So if D2 is equals to 0, and then we need to check in on segment PQ, and if this is satisfied, then we are going to return true. Similarly, if D3 is equals to 0 and on segment, so here R and S was the segment and P was the point, then we are going to return true. Otherwise, we are going to check if D4 equals to 0 and on segment RS and Q. If this is satisfied, then we are going to return true. And if none of these conditions are satisfied, then the points do not intersect each other, in which case we are going to return false. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the direction function. So PQ is the line segment and R is the point. So we form our two vectors, PQ and PR, and then we have computed the cross product of those two vectors. Similarly, for on segment, if this condition holds, then they are on the segment, otherwise false. Once we have these two functions with us, then we are checking whether they intersect or not. So in order to discuss the intersect, we first computed the direction of each of the points with respect to a line segment. And then we are checking whether this condition is satisfied or not. If this condition is satisfied, then we are returning true. Otherwise, we are checking whether a point is on the segment or not. If the point is, or if one of the point is on the other segment, then we are returning true. If none of the condition is satisfied, then we are returning false. So that's this Python implementation, folks. Now let us submit our solution. So our Python implementation got accepted. So that is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.